So the last topic that we are going to look at is a review of the last topic you looked at in grade 11, which were reciprocal graphs. Okay? And we've kind of looked at this idea already in chapter 2, but since there has been in the past a fair number of questions on the final exam that look at these ones in particular, what happens when you have 1 over a function? What happens to that graph? We're going to review that grade 11 topic now and sort of get you ready for it for the exam. So it's a special transformation. It's a reciprocal graph. Some special transformations we've already done. We've done square roots of graphs. We did that in chapter 2. And so this is looking at what happens when you know how to graph the original function, which is on the bottom. How can you graph 1 over that function? Now, the basic idea is really simple. With all of our transformations that are special transformations, like the square root of a graph, all that we needed to do was square root the y value. Same thing happens here. If we do 1 over our original graph, the only thing that's going to change is our y values are going to become 1 over y. Now, although that sounds simple, there are some crazy things that happen with reciprocal graphs. And reciprocal graphs usually look nothing like the original graph that you started with. So we're going to look at what are some of the special things that happen and ways that we can graph things quicker and easier. So I've sort of set it up into a number of steps for graphing it. First of all, you would draw f of x first. So whatever the graph is on the bottom, you'd use your regular transformations to graph that. And I've got a number of examples that we're going to go through that are going to help you see that. Then on a separate graph, and sometimes they allow you to do this even on the same graph on a final exam, what you're going to start with is you're going to look for your x-intercepts. And you're going to draw vertical asymptotes where you have x-intercepts. And the reason for that is if the only thing that's happening is your y values are changing to 1 over y. What are the y values at an x-intercept?
0.
They're 0. And if you have 1 over 0, that makes a non-permissible value. So it makes sense that you would have either a hole or an asymptote here. But what's going to happen in all 1 over f of x graphs is you will always have asymptotes. So that's your first thing. And in these notes that I've given you, whatever is the bold part in these steps, that's the important thing. And whatever is unbolded is sort of an explanation for that. So here you see in the explanation that I say, well, if I have an x-intercept like 3, 0, and I change that y value to 1 over y, that point changes to 3, 1 over 0, and that's not possible. So that's why we have an asymptote. You're next going to look for your horizontal asymptotes. Now for this, with all 1 over graphs, if your graph goes on forever to infinity, then you're going to have a horizontal asymptote on the y-axis, or on the x-axis, sorry, you're right. And it's going to be y equals 0. Now, if you look at 1 over x cubed, you could also use the technique that we used in chapter 2 to find out horizontal asymptotes. Remember in chapter 2 we would say, well, what's our highest degree of x, or what's our highest power of x? X cubed. We have 1 x cubed on the bottom. How many x cubes do we have on the top? We have none. If we simplify this, this goes to 0. And that was our technique to find horizontal asymptotes in chapter 2. So you could use that as well. But what you're going to find is all of the 1 over f of x graphs, if they have an asymptote, then it's going to be at 0. So any graph on the bottom, so if I used 1 over x squared, well, you know that an x squared graph goes up forever. Or if I had 1 over negative x squared plus 5, well, that would be flipped down, moved up 5. Hey, we had that graph yesterday, didn't we? The football graph. It goes down forever. right? So any graph where either your y values go up forever with your arrowheads or down forever with your arrowheads, you're going to get that asymptote at y equals 0 on the x-axis. Graphs that won't have this, if I pick the sine graph, can you see the sine graph only goes up to 1 and down to -1? So it stays in between those two values. It never goes up forever or down forever. So a sine graph, when we graph 1 over sine x, it won't have an asymptote at y equals 0. But we're going to look at the reciprocals and graphing cotangent, cosecant, and secant next, after this. So once we've done both of our sets of asymptotes, then it's a matter of plotting some points. What you're going to look at is certain points. Some points are nice, like 3, 1 in the example here. Anytime your y value is 1, does it make sense that it's not going to change? Because 1 over 1 stays the same. So here I say plot all the points on your original graph where the y-coordinate is 1 or equal to -1. In step 5, it says do the transformation 1 over y for other points, maximums and minimums. For the most part, we're going to do steps 4 and 5 together. And you can do other points if you want as well. So for example, if you know you have the point 3, 5 on your original graph, you now will have 3, 1 over 5 on your reciprocal graph. And so if you know specific points on your original graph, it's going to be really easy to figure out where they're going to go on your next graph. But maximums and minimums are important points, because if you have a maximum on your original graph, when you do the reciprocal, it's going to be a minimum on your other graph. And then finally, you're going to just connect your points and draw what we say is asymptotic behavior. You're going to draw your graph towards the asymptotes. So again, like we've done before, you'll have points in each section of your graph, and then you'll be able to figure out what's going to happen to my graph at that point. So this allows us to review a lot of the same ideas that we did in Chapter 2, and also review some of the stuff that you did already in grade 11. So you've got this handout. When I did it originally, I broke everything up into like step by step so you could see what would be the next thing that you would draw if you started off with 1 over x squared minus 4. Now this wouldn't be all the work you would need to show if you were doing this question. So we're going to do this one together, and we can do it. I'll just do it right beside this original graph. So you would start by drawing your original graph on the bottom. X squared minus 4 is a parabola that's been moved down 4 units, and that's right here in this graph. So right beside it, I'm going to go through all the steps that we listed before. So what you're going to do is you're going to start with any x-intercepts. You're going to start with all of your asymptotes. And you're going to say, do I have any x-intercepts? Yes, I have an x-intercept at -2. I have an x-intercept at 2. So I can draw vertical asymptotes at x equals -2 and x equals 2. Step 1 done. Horizontal asymptotes. Does our graph go up forever? Yes. So we will have a horizontal asymptote at y equals 0. Steps 4 and 5. This is where you're going to look at your maximum and minimums and other nice points. So if we think about our original graph, do you see that you have a minimum at 0, -4? Your new point then will be 0, comma 1 over 4. Because remember, the only thing that changes is your y values would become 1 over y. What are some other points we know on this original graph? Well, I have 0, comma 4. Can you see that you would have 1, comma negative 3, 2, comma 0. What happens when I plug in 3? 3, comma 5. And over here you would have negative 3, comma 5. So it's not hard to find a bunch of points on your original graph. And once you have a bunch of points on your original graph, you can plot them on your reciprocal graph. What's going to happen to 1, negative 3? Oh, this one I forgot the negative here, right? It's going to become 1, comma 1 over negative 3. What's going to happen to 3, comma 5? It's going to become 3, comma 1 over 5. And same thing, negative 3, comma 5 will become negative 3, 1 over 5. So what I've done is I've taken some of the points that I know on my original graph and I graphed them. One little difference that I have in the example that I'm doing off to the side that I did over here but I'm not going to do on my graph is over here I tried to find where the y values were equal to negative 1, right there and there, because they won't change because 1 over negative 1 stays the same. But I don't know the x value. So it wasn't a very nice point, so it's okay to leave it. You don't have to do the values where y is equal to 1 and negative 1 if you don't want to, because you might not know the x value. And once I have the points that I have here, you can go to that last step which just says, draw your final graph. You know that your graph has to go towards your asymptotes. So in this case, since we've got a couple of points in each section, we can just draw the asymptotic behavior. Did you guys have a name for these graphs? That's sad clown. Nice. Okay. Example number 2. Same idea. But here we have x squared plus 1. So just like last time, although all the steps are given to you there, we'll work through them with one graph, because that's what you would do on an exam. You would just start from your original graph, draw your original graph on the bottom, and then be able to sketch your reciprocal. Are there any x-intercepts? No. So there will be no vertical asymptotes. Does our graph go up forever or down forever? Yes. So we will have a horizontal asymptote at y equals 0. And then when we go to our points, if we look at our original graph, we have 0, comma 1. We have 1, comma 2. Again, when you're trying to find points on your original graph, you can just plug in values for x. You see when I plug in 1, 1 squared plus 1 is 2. If I plug in 2, I'll get 5. And this is a parabola, so it's going to be symmetrical on the other side. And just like that, we have 5 points. What's going to happen to negative 2, comma 5? We're going to get negative 2, comma 1 over 5. What's going to happen to negative 1, comma 2? Negative 1, comma 1 half. What's going to happen to 0, comma 1? 0, comma 1 stays the same, and then you've got 1, comma 1 half, 2, comma 1 fifth, and now if we draw the asymptotic behavior, and yes, you called this one a speed bump. Nice. So again, when you do all of the steps onto one graph, basically what we're doing, if you wanted to simplify our 6 steps into 3, step 1 is draw the original graph. Step 2, asymptotes, right? Vertical and horizontal. If you just call that one step, you can remember those both together. Step 3, points. Do a bunch of points and draw it. So I said 3 steps, so I put that draw it. Points and draw it. Because that's part of drawing it, is getting some points on there and then drawing it. So it's not that bad, but the idea stays the same every single time. So for all 1/over graphs, if you have your original graph, you can then graph your reciprocal. So here we have 1 over the square root of x plus 4. You would start by graphing the square root of x plus 4, which from transformations is your square root graph moved 4 to the left. And we have that right here. Now right beside that, starting with asymptotes, do we have any x-intercepts? Yes, at -4. Does your graph go up forever? Yes. Square root slowly gets larger and larger, not as fast as a parabola, but you will have an asymptote here at y equals 0. Good. Done the asymptote part. Step 3 is points and graph. So if we look at our original graph, we've got -3, 1, 0, 2. If you wanted another point, what would be the next nice point on this graph? 5, 3. Again, look at your equation. We're doing square roots. When you plug in 0, you get the square root of 4. That's a nice number. The next nice square root that you can do would be the square root of 9. What value of x could I plug in there to give me that square root of 9? That would be 5. So that's how you can find some points on your original graph. Now that you have those points, well, what's going to happen to -3, 1? It's going to stay the same because you'll have 1/1. 0, 2, 0, 1/2. 5, 3, 5, 1/3. And so this wasn't one of the graphs that you would have had last year, because all of your graphs last year were 1/over parabolas or 1/over lines. You never did a 1/over square root. So you didn't have a name for this one. We can make up a name for this one. Boomerang. Boomerang. Or L. It's an L. Okay. And so now we can have any function on the bottom of any of the transformations that we did so far. And so that adds to what was in grade 11. But the process stays the same. The other thing that could happen is they could just give you some random graph and say graph 1 over that. So here's a random graph. Yeah. That is the Pikachu tail graph. And now you want to take that graph and do those steps. So again, even though I've got all the steps separated here, let's do it right beside. Starting with asymptotes. Do we have any x-intercepts? Yes, we have a bunch of them. We have one at -1, we have another one at 2, and another one at 5. So at -1, at 2, and at 5, we have x-intercepts, so those will become vertical asymptotes. Does our graph go up forever? No. Oh, yeah. There is an arrowhead here on this side. On this side, it stops, but there is an arrowhead over there, so yes. we will have an asymptote at y equals 0. So we're done our asymptotes. The last thing is just a bunch of points. Now, the reason I have this example here is I want to show you what happens to a straight line, a straight horizontal line. Can you see that -5, -1, what's going to happen to that point? That's going to stay the same. So we're still going to have -5, -1. And -2, -1. It's going to stay the same. And horizontal lines stay horizontal. Even if they change, can you imagine a horizontal line where all the y values were 4? They're all going to become a straight line that are 1 over 4. So horizontal lines stay the same. Next point that we have, 0, 1, that's going to stay the same. Another point we have is 4, -1. That's going to stay the same. And we have 6, 1. That's going to stay the same. Now, we have a bunch of points, but if you're unsure of where the graph is going to go from here, you can invent some more points from your graph. So, for example, it looks like right here on my original graph, my y value would be 1/2. Does that make sense? What's the reciprocal of 1/2? 2. So if you didn't know that this graph was going to be going down towards your asymptote, once you get that extra point, you now know it will go down. In fact, if you do all the places where it's -1/2, like here it's a -1/2 again, here it's -1/2 again, so those will all be places where it's 2, all of a sudden you figure out this section needs to go down. And you could do +1/2 as well if that would help you. What's going to happen when it's +1/2? That's y value is +1/2 here, here, and here. Well, it's going to be 2 in each of those sections. And so by now, you might be able to figure the rest of your asymptotic behavior. Things to be careful with reciprocal graphs. Right? You get so used to putting arrowheads on places because you don't want to lose a 1/2 a mark for forgetting your arrowheads, that sometimes you add arrowheads where you shouldn't. Right? You're going to be like, got arrow, yeah, oh, put one there. Okay, you did that? All right, there are some people that already did that. Now, that's tempting, but look, our original graph doesn't keep going there, so our other graph has to stop there as well. So be careful with your arrowheads with these graphs. Okay, I've got some questions for you.